In this video, I'm going to explain to you the theorem of dimensions. And this is a theorem that relates the dimensions of the range, the dimensions of the null space, and the dimensions of the input space. It's a beautiful theorem. Let's go into it. So first, let's give things some names, okay? So the input space has a dimension n, that's clear, and the output space has a dimension m. Now, the range, which is the subspace into which all of the input space is mapped. So let's call the range to have a dimension called the rank. Okay, so let's say that the number of dimensions of the range, let's call that the rank. And for the null space, let's call that the dimension of the null space, the number of dimensions of this subspace, is equal to the nullity. So in some way, you could say that the dimension of the range, so the rank, yeah, so the dimension of all of this, it must be smaller than or equal to the entire input space, right? That makes sense because you start with a certain input space, and either you map vectors 1 to 1 when the determinant of the matrix is not equal to 0, in which case the number of dimensions should stay the same because every vector in the input is mapped to a single vector in the output. Or if the transformation is squashing things, we are reducing the number of dimensions, yeah? So the dimension of this space here must be smaller than or equal to the dimension of the input space, yeah? So let's write that here. So rank should be smaller than or equal to n. But now, notice that the null space, which is this green circle on the left on the input space, this null space is being squashed into a single point, a zero-dimensional subspace. So we have this null space, which has a dimension equal to nullity. Maybe it's a line, or maybe it's a plane within the 3D space or something. It's a subspace of the input. And this subspace has a certain number of dimensions. Maybe it's one-dimensional, two-dimensional, but it's being squashed into a zero-dimensional point. So we are kind of losing this number of dimensions in the process, yeah? But if you think about it, the squashing is the same everywhere. This is a linear transformation. So if you are squashing this null space, you are squashing all of the input space by the same amount. So you can say that this number of dimensions are being lost, okay? So if you take the input space, which is n-dimensional, and you subtract the dimension of the null space, which is the amount of dimensions being squashed, the result is the dimension of the range, which is the rank, okay? So let's write that formally. The dimension of the range of A is equal to the dimension of the input minus the dimension of the null space of A. So the dimension of the null space is telling us how many dimensions is this transformation squashing. Yeah, it's a very, very profound statement about the dimensions in a linear transformation. Now, since we gave things our own names, so the dimension of the range, we said this was called the rank of A. The dimension of the input, we were calling it n, capital N. And the dimension of the null space, we said we were calling that the nullity. Okay. So this is the theorem of dimensions. To summarize all the words and concepts, let me write down this table very quickly. So let me explain this table. On the left column, I just write different spaces, like the input space, the range of A, and the null space of A. In the center column, I write the dimension of this space. And remember, the dimension is a number, it's an integer, yeah? So it's n for the input space, it's equal to the rank for the range, and it's equal to the nullity for the null space. That's simply how we call this number. Such that we have the theorem of dimensions, rank of A equals n minus nullity of A. And then in the third column, I have just written the spaces as a span. So the input space is a span of the basis vectors. Let's call this basis vectors of the input, yeah. While the range can be written as the span of the columns of the matrix. So in the next video, we will see examples of calculating range, calculating null space, and checking the theorem of dimensions. Thank you very much.